Okay, today we're going to keep working on AA13, which is add, subtract, and multiply monomials and polynomials. And this is part of Chapter 11, Section 4 in the AMSCO Integrated Algebra textbook. And the main question here is, how do we find the product of the sum and difference of two terms? Okay, so our vocabulary: sum, difference, product, and terms. Okay, first of all, the question is, what is the sum? What is the product of? And I wrote these in parentheses here so you can see the product. The sum and difference of two terms. Okay, so that's the product of something. So I'm going to write, this means the product, right? Two things being multiplied. The sum and difference of two terms. So the difference of two terms, like, let's write that here. Okay, now the sum of those very terms would look like that. Okay, so our real question is, how do we find the product of these two binomials? And there are particular types of binomials where one is the sum and one is the difference, but the terms remain the same. They both have x and 10 here. Okay, now we have seen this before, so if I just look at this real quick, we can sort of develop the general rule. We've seen this is a special type of binomial that we've discussed before. If I do, first of all, since it's a binomial multiplication, we can always use FOIL. Okay, FOIL is for a binomial times a binomial. So I do x times x, which is x squared. Now the next term is x times negative 10, because remember, you want to think of that minus 10 as negative 10. Okay, and the inner terms is 10 times x, which is 10x, and the last term is 10 times negative 10, which is negative 100. Now when we start adding these together, you're going to see that these two cancel, they get 0. So what we have here is x squared minus 100, and you will recall that we called this the difference of squares. Okay, so the product of the sum and difference of two terms is the difference of squares. That's how they relate to each other. Okay, so the general rule I've written above, if you have two terms a and b, and you're taking the product of a plus b and a minus b, you just get the first term a squared minus the second term b squared. Okay, so in this case, our a is equal to x, and our b is equal to 10, because you'll notice b doesn't have a sign on it. B is just that term that's right after the sum or difference. Okay, so here, oh, I just did this one randomly. Whoops. So here we saw that, a squared, if a is x, then a squared is x squared, and if b is 10, then b squared is 100. So just putting that into the formula here, a squared would be x squared minus b squared would be 100, and that's what we had before. Okay, so the example number 2 is I've switched the constant and the coefficient around, but that's okay with us. A in this case, for these two binomials, would be 8, so a squared would be 64. B is, well, it's b, right? That's b right here. So b squared would just be b squared. Okay, so fitting into this general rule, these two binomials, the product of these two binomials would be a squared minus b squared, so it's 64 minus b squared. That's it. Okay, for example number 3, here we it gets a little trickier. Our a is 9x squared. Okay, so our a squared is the square of 9x squared, and this is why we learned how to square a monomial in the previous lesson, because we're going to use it in this lesson here. Okay, so we have this 9x squared is a monomial, so I need to square all parts of it. So I have 9 squared times x squared squared. That's 81x to the 4th. Okay, and then b is equal to y, so b squared is equal to y squared. Okay, so here I'll write the answer to this problem in blue. This right here is equal to 81x to the 4th minus y squared. Okay, and that's our shortcut. So basically all we're doing here is we're finding the F and the L terms because the O and the I terms cancel out. Those are zero pairs, right? They're additive inverses to each other. So really, this general rule is just giving you the product of the first two terms, the product of the last two terms of the binomial. Okay, so in this case, the term that's standing in for A is actually B, the way we wrote it. Okay, so A squared is going to be B squared. And the term that's standing in for B is 4A squared. So B squared is going to be 4A squared squared. Okay, well, that's 4 squared times A squared quantity squared. Okay, that's 16A to the fourth. So here, the answer to this is going to be B squared minus 16A to the fourth. All right, and then our next problem here. All right, so we changed it up a little bit because the coefficient is a fraction. Okay, but notice it's, the first term A is 7/8 C. Okay, and B is the term D, is the variable D. All right, so A squared is going to be 7/8 C quantity squared. Okay, and let's just do that's 7/8 squared times C squared. Okay, well, 7/8 squared is 7/8 times 7/8, which is 49/64. So we have 49 over 64, and then C squared is C squared. Okay, so our second term that's standing in for B in the general rule is D. So we can see that B squared is D squared. Okay, so our answer is going to be 49 over 64 C squared minus D squared. Okay. And for our last one, so this one's a little trickier because this is the product of three binomials. The first two binomials are the sum and difference of two terms. So let's go ahead and find that. So whenever we have three binomials multiplied together, we do them two at a time. Okay, multiplication is what we call it's an operation that takes in two things at a time. Okay, you can't do three things at a time. If you were multiplying, three numbers together, you'd always do just two at a time, like that. And binomial multiplication is the same way. It's called a binary operation. A binary operation is something that takes in two things at a time. Okay, so most operations are binary, like addition, subtraction, and division. Those are all binary operations. Okay, so for here, let's just focus on the product of these two binomials first, and then we'll deal with this last one. X minus y times x plus y is going to be x squared minus y squared. Okay, because our a is equal to x, so a squared is x squared. And our b is equal to y, so b squared is y squared. Okay, and fitting those into the general rule, we have that. All right, so we've multiplied those two things together. Now let's bring down the x squared plus y squared here. And what you should notice is that now in the second round of multiplication, that again we have the sum and difference of two squares. That's the way that this is set up. Because here, they both have x squared to begin with. Okay, they both have x squared to begin with. And then they both have y squared to end. Okay, so let's see. So let's erase some of this stuff over here. We can do work. So our a term is x squared. So a squared is going to be whatever a was squared, which is x to the fourth. Okay, and our b term is y squared. So similarly, our b squared term is going to be y to the fourth. Okay, so when I multiply these two binomials now, I'm going to have x to the fourth minus y to the fourth. Okay, and again, this is x to the fourth minus y to the fourth is the difference of squares because x to the fourth and y to the fourth are both square terms. Okay, a square term is any term that has a square coefficient and a variable raised to an even power. So x to the fourth, because it's considered 1x to the fourth, has a perfect square as a coefficient, 1 is a perfect square, and it has a variable raised to an even power. So if I took the principal square root of it, I'd get back x squared. Okay, and that means that both x to the fourth and y to the fourth are square terms. Okay, our next one again has three binomials, but they were chosen very carefully. So you can see, you're going to see in just a second how easy it is to do all three of these. So first, again, we do two at a time. Here, our a term is 4, so a squared is 16. And our b term is a, and so b squared is a squared. Okay, so these two multiplied together would be 16 minus a squared. Okay, and we'll bring down this last binomial. And you'll see again that they were chosen carefully so that when you found the product of the first two binomials, you would have the sum, the difference of two terms, and then when you multiplied it by this third binomial, that's the sum of the same terms. Okay, so for these two binomials, the a is 16, so a squared would be 256. That's 16 squared. And our b term is a squared. Okay, that's standing in here for our b. So our b squared term would be a squared squared. So our b squared term would be a to the fourth. Okay, so here we'd have 256 minus a to the fourth. Okay, so it turns out the product of all, the product of all three of these trinomials is equal to 256 minus a to the fourth. Okay, and our final example here, it gets a little bit more complicated because we have y to the third. But again, we'll do them two at a time here. So let's see, we have our a term for the first two binomials is 5y to the third. So our a squared would be 5y to the third squared, which is 5 squared y to the third squared. So it's 25y to the sixth power. And then our b term is 8, so b squared is 64. So the product of these two right here is 25 y to the 6 minus 64. Okay, and then we bring down that last binomial. Oops. Okay, and we multiply these together, but you'll see here the terms of the a terms are the same and the b terms are the same. So our a term is 25y to the 6 now. So a squared would be 625 y to the 12th. Okay. Okay, and since our b term is 64, b squared, oh, I'm going to have to do that out. Hold on one second, I'll pause the video. Actually, let me just take this opportunity to show you a quick way to using FOIL, actually, with a number. 64 squared is the same as 64 times 64. But 60 can be decomposed into two parts. We can write it as 60 plus 4 times 60 plus 4. Okay, so if I do FOIL on this, because it's essentially two binomials, they're not really binomials because they can actually add together, but I can use the same thing. So 60 times 60 is 36 with 2 zeros, plus 60 times 4 would be 240. We're going to have that again here, 240. And then 4 times 4 is 16. So actually, if I line these all up, I could add them together quickly, and I'd have 4,096. And that is the end of that problem. Okay, and that's the end of the lesson.